without further ado, I want to bring up another one of our sponsors who's got some great insights from AMD. Please put your hands together for Chris Sosa. Bring it up with the glasses, buddy. Good job.
All right. All right. Let's see where we are. Aha. There we go. There's my beautiful face. Hi. My name is Chris Sosa. I am a director of engineering at AMD. Specifically, one of my jobs, and probably my most important job, is to take all of the AMD GPUs that we have available, either our Instinct line and our Radeon chips, and make them available for developers externally as well as internally. So, how am I doing that? I'm building a developer platform, and I'm making that available for all those different developers. So let us jump into sort of what actually I'm here for. So I'm actually here to talk about a few different things. So I'm going to start off by giving you kind of just an overview of the AMD's sort of like overall AI software offering. It's not my main goal here, but I just wanted to make sure we're all on the same page in terms of what I'm talking about. So I'll explain a little bit about like what ROCm is and what else we're doing. If you went to the breakout room, at least a little bit of that will be boring, but I'll try to sort of jump through that and actually skim through that as much as possible. But I'm here to talk a little bit about scale. And when I think about scale, there's sort of like 3 areas of scale that I'm thinking about. So the first area of scale that I want to talk about is developers. So developers in the greater ecosystem. As you all know, like AI is powered really by a large ecosystem of different projects and different software. And as part of like the overall AMD offering, we actually leverage a lot of that. And so talking about how we're are empowering developers, where some of the challenges are today, and actually where we're trying to improve. Second part of scale is about people. So great folks talking a lot about like how do you leverage people, how do you build for people. When you have 100 machines, you have 100 servers with thousands of GPUs, you're not actually, you're not building it for one wonderful workload to run really well. Like you have heterogeneous workloads, and not only heterogeneous workloads, but you're working with like, at least at AMD for us, we have like 15 different departments with thousands of engineers who need to be able to have different types of workloads run on those systems. And at the same time, as someone who is administering the kind of platform, like, how do you really drive up utilization of the platform? How do you make sure it's really easy? Like, we just heard a talk about sort of infrastructure as code is providing templates. Like, that's actually really important. But also just like how you really drive up utilization from the perspective of both optimizing workloads as well as sort of optimizing people. And so the last thing I'm going to talk about is just sort of some of the challenges at building sort of like any kind of platform with like, hundreds of machines, thousands of machines. You actually have a lot of problems at scale. Some of those are similar to some of the challenges you have with building any kind of servers. Some of those are specific to building a bunch of servers with GPUs that you're trying to utilize. So that's kind of an overview of what I'm going to talk about. But yeah, let me talk a little bit about, oh, I jumped ahead. Oh, wow, okay, never mind. I had an overview slide about software, but let me talk a little bit about what ROCm is before I jump into some of the feedback. So ROCm is composed of a bunch of different layers. So at the sort of bottom layer, we have a bunch of tools in terms of interacting with the GPU. Above that, we have math libraries and we have compilers. But you can think about what ROCm is effectively a kind of like the set of drivers and software stack that if you want to run any kind of like inference engine or framework on top of, effectively, you have everything that you need available to sort of implement what you need on a single machine. On top of that, in the ecosystem, on top of that, if you're actually trying to build out any kind of MLOps platform, of course, you need a lot more things that require a bunch of servers. So things like observability, like dashboards, like you're using Prometheus, you're using Grafana. If you're likely using some sort of job orchestration like Kubernetes or Slurm to actually build on top. And there's a bunch of integration points where, as part of our AMD software offering, we provide a GPU operator as well as several components that can be leveraged either as part of a platform that integrates well with our operators or sort of can be used alone on an individual machine. That's just kind of like what ROCm is. It's a driver stack as well as our AMD offering has a lot of components. Those components are interchangeable, and so you can leverage like frameworks such as PyTorch and a few other inference projects as well as training projects you will use on top. But one of the things that is critical, and if I had that slide that had the full stack, is effectively, and this is true of any kind of like AI stack, you need effectively to leverage the ecosystem. So developers are actually really critical, not just within AMD, but outside of AMD. Like empowering the developers is actually a critical part of like what we need to do at AMD. So I'll talk a little bit about sort of what we're doing and what we've heard. So one of the things first we've heard about in terms of like what we've heard from the community is one of the challenges with AMD GPUs is they're actually hard to access. So we just had a talk about Vultr about providing instant machines, but a lot of the feedback we've heard, especially with ROCm, is that developers really want to leverage the machines that they have available to them, and they want to be able to develop with the machines that they have available to them. So this means having a workstation with a Radeon chip, right? And a Radeon chip may not be like the most recent Radeon chip, but they want to be able to like contribute to PyTorch, run an inference using ROCm, and contribute to ROCm with effectively the Radeon chip they have. And most of them also, a good chunk of them will have Windows, right? And so, hearing this feedback, I think one of the big things that we're excited to talk about is sort of like coming in the next set of ROCm is these changes to really kind of empower developers. So we're looking to have a truly open source project. So even though the ROCm is an acronym that doesn't actually mean anything, the intent of ROCm was to be an open source project. But we've kind of fallen a little bit short of that, and we're actually looking to change that as part of 7.0 so that the community and AMD developers are able to actually work from the same code base. Looking to have smaller release artifacts. It's also been a big complaint, just the size of our artifacts have been big, and actually treating Windows as a first-class citizen. We're actually hoping to support the last 10 years of Radeon chips so that developers, if they have a Radeon GPU, they can actually contribute to ROCm and actually get the most out of PyTorch and actually do training just on their own machine. And in addition to developers, there's of course all of the projects that they contribute to. So here's a handful of projects where we've provided actually instinct machines through various CSPs and enabled them. So PyTorch is one of the largest ones where we've treated some of the most machines. We've actually doubled our investment in terms of our GPUs available for PyTorch developers to leverage as part of their CI systems and test automation systems. And we've also done similar for SGLang and VLLM. And we've just recently enabled a lot more testing with Hugging Face. So our intent is that every ecosystem project that needs machines will get AMD GPUs. And we are working as carefully as possible with any kind of project that we care about to make that happen. So yeah, that's about developers in the ecosystem. That's kind of like the first pillar of scale that I think about, that we care about at AMD. The second is really about like, okay, so like we talked a lot about like running inference on a single machine, but what about building a platform, right? The previous talk talked a lot about usability, about using infrastructure as code, using templates, but when you're actually having a lot of different consumers of your platform, like actually how do you build it, right? And the reality is you're composing a platform out of a lot of open source technologies. In general, there are like platforms as a service you can consume, but effectively, if you really want to build for developers, you're often more or less building a bespoke developer platform, leveraging what is available. So here's a handful of technologies that we recommend, but this is not extensive in terms of it's not. There's a lot more projects here, right? But this kind of covers like a quick area. But one of the things we're trying to provide at AMD is a set of blueprints to actually make this a lot more easier, because there's a lot of choices, a lot of decisions you can make, and it's hard to navigate that on your own. So just to name a few in terms of some of the problems they're solving, and one of the key ones I want to call out here is kind of the one in the center, this project called Longhorn. One of the challenges you have with any kind of distributed inference or distributed training is how to deal with storage in a coherent way. Like, yes, you can put an NFS, get that storage, but actually making that usable and having a more cloud-native solution, you actually need a solution to that if you want to scale. Because one of the challenges that you have, especially when building any kind of multi-tenant platform, either using Slurm or Kubernetes, is you kind of can't exactly get developers to completely change their workflows. Like if you're someone who's building a platform, you're both chartered with trying to optimize the utilization of all the GPUs you have available, while also trying to get developers on board to leverage your platforms. And while you can control the production environment, like if you have a set of inference or training workloads that you have to run, you can optimize that, but you also have to optimize for developers who also need to access those GPUs. And that's where a lot of these technologies are actually, I found really valuable, since that's a big charter of what I'm working on. But yeah, more to come there in terms of blueprints. This is a challenge, just building these kind of platforms. So now I kind of want to get to the last pillar of like scale, which is just like, how do you deal with a bunch of machines? The two kind of problems I want to talk about a little bit in terms of like, so the challenge is what AMD is doing to help with those challenges, but also generally like how you can work on those challenges are, one, how do you optimize the utilization of your platform? So I don't know about you, but one of the things that is kind of a key requirement for me when building this platform is, from a stakeholder perspective, they want to see overall utilization of every GPU at like 70% or above, right? And that's actually really expensive when you have thousands of machines, like actually getting all the workloads to be fine-tuned so that you can really maximize it. Because even for AMD, like servers are expensive. We want to maximize our use of our GPUs. So I'll talk a little bit about how to kind of like monitor utilization, how to get up there. And there's a lot of approaches, and there's a lot of simple things that you don't always think about. And of course, there's a lot more advanced things like smarter orchestration that I'll talk about a little bit as well. And then the second thing, GPUs do fail. They fail like hard, they fail soft, right? So what do you need to do in order to like kind of scale, build a platform, make sure your machines are up? So the first of these actually kind of covers sort of driving up utilization. There's a lot of approaches here. I will talk about I'm talking about this more from a distributed perspective. I'm not going to talk about inference. Like there's a lot of ways to optimize, compile your models and kernels to run really well on AMD GPUs. That's about single workloads. I'm thinking more about how do you optimize for heterogeneous workloads where you're running a bunch of different workloads. And one of the key things that we're seeing, especially with our partners in the ecosystem, and these are a couple that we talk about, so with the RAP and Exastel, is how do you do smarter orchestration as part of a platform? Because you can really maximize, you can really grow the actual value and utilization of how much you're really getting out of your GPUs by effectively bin packing workloads. So I encourage you guys to check out some of these partners, but once you get to optimizing for single workloads, you start needing to try to bin pack and optimize those workloads, and that's where smarter orchestration is critical. Sorry. And then a couple things that we're also kind of doing in this space. We're also enabling sort of fractionalized access to our GPUs. One of the key things in that area is just how do we sort of plug and play and insert that into our overall operator stack. So great thing about fractionalization is you can kind of optimize your workloads to leverage them. But one of the challenges is actually trying to figure out how to right-size your workloads to actually figure out the right fraction. And that's where the intersection of smarter orchestration with leveraging some of the underlying technologies like CPX, DPX, and QPX, which are just taking a single GPU and dividing it to its undercomponents, so you effectively get 1/8 or 1/4 or half of the GPU and can leverage that chunk. And that kind of helps drive up utilization because you can really optimize for the amount you need. And then I've only got a couple minutes left, so I'm going to jump to the last section, which is how do you deal with problems when GPUs fail? So on our side, one of the things that we built in one of our platform is actually the GPU, an AMD operator, and any kind of operator you're working with, either with whatever your hardware manufacturer choice. We add a lot of health checks. So we have a lot of health checks that we deliver as part of our operator and part of the platform. One of the key things that you probably want to think about, and there isn't really a standard solution in this space, is how do you quickly repair things? So if you're building on top of a CSP, one of the challenges that you have is you don't have as much control, right? You can't obviously you would love to re-image something if it really goes bad, but you don't have that control. You have to file a ticket. So but there's a lot of things, a lot of automation you can do when you detect something on a GPU, and the faster you can detect it, the faster you can perform a set of operations. And so one of the things that that we've learned is having a composable way to do repair steps for GPUs when they fail. Even a simple reboot of a VM or a server can really bring up effectively and actually reduce your overall downtime. Because again, you have 100 machines, you're likely going to have 1 or 2 go down probably once a week, right? Getting those back up very quickly, you're still trying to overall optimize not just the utilization of the machines you have online, but the total set of machines you have available. And so looking at hot swap technologies for when you're in CSPs and you don't control bring up, But even if you're on a bare metal data center where a lot of like the fleet that I manage, like being able to get those back up quickly is actually really important. Anyway, and sort of just to finish off this talk, just kind of gave a quick overview of like AMD's software offering in terms of AI. And I also talked about the 3 dimensions of scale and what we're doing, in particular how we're empowering developers in the ecosystem, how we're dealing with, how you deal with people and having a bunch of people leverage the same platform and building the developer platform. And then finally, how do you actually deal with a bunch of machines? So anyway, thank you so much for your time and have a great rest of your day.